this chemistry lecture, we are discussing about periodic table, that means classification of elements. Now keep in mind, if you are not from science background, then you will not able to follow whatever I am teaching over here. In order to get this knowledge, suppose you are from science background, then you may follow, but if you are not from science background, you are not able to follow whatever I am discussing, because now I am considering that you are aware of atomic structure, you are aware of electronic configuration, you are aware of chemical bonding, and then you are going to observe this, and certain parts of physics also, that is radiation, energy level, all that. So my request is there, if you are not from science background, or if you are not able to follow this lecture, then first observe atomic structure lecture, electronic configuration, make practice of electronic configuration thoroughly, then go through chemical bonding concepts, octet rule, etc. Then about radiation also we have to discuss something. Now we are discussing about classification of element. I am not going to discuss in history. We are just observing how elements are classified. Now you are aware what is element and what is compound, what is mixture. You are aware there are elements. You are aware how to calculate number of proton, neutron and electron from that element. You are aware how we are writing out an element. For example, here I am writing out something. This is name of element, symbol of element. Here we are writing out A, and here we are writing out Z. What is Z? That is atomic number, and what is A? That is atomic mass number. Now there is instrument that is called as mass spectrometer. By using that mass spectrometer, one can find out atomic mass or atomic weight, which is different from atomic mass number. In earlier days, they were considering atomic weight as characteristic of an element, but now we are considering atomic number, that is Z, as characteristic of an element. What is modern periodic law given by Mosley? It says all chemical properties of an element are periodic functions of their atomic number, whereas old law given by Mendeleev, that was saying it was periodic function of atomic weight. So only change is there, that is atomic number we have to consider. But when we produce the periodic table, we are calling again and again that as modern periodic table, or simply now we are calling as periodic table. So what is modern periodic table? That is based on atomic number of element and not on atomic weight. But it is not only depending upon atomic number. Apart from atomic number, we are considering electronic configuration also as classification characteristic. Now why we want to classify element? Question is there before starting out this chapter. My question is there, why we want to classify these elements? Answer is that when we are studying out element, various elements are showing similarities in properties. Some elements are showing extreme similarities in chemical properties, and we want to find out relationship. With modern periodic table, we can find out this relationship easily, and in order to make comparative study easier, in order to make fast study of chemistry, and in order to study out certain chemical properties, we required classification of an element. Earlier classification was very simple, metal and non-metal. Yes, because at that time number of elements discovered were very less. Then we discovered certain elements which are showing both characteristic, metal and non-metal. So classification again changed out, metal, metalloid and non-metal. But now we are aware that only this classification is not sufficient, and for that purpose we are now discussing about modern periodic table. Again, we are starting out, yet I have not started the chapter, but my request is there, as we discussed in geography, that you have to draw map with me. Same thing I should say here, that you can draw periodic table with me. In earlier lectures I have discussed that at least 1 to 20 atomic number, all elements you must by heart. Yeah, now that is useful to study out this. So try to draw periodic table with me. I am drawing here periodic table. Follow the step, and on requirement you can pause this video and try the concept again and again. Now here I am drawing first part. I am drawing here first column. In this column we have to make row 1, 2, 3, 4, 5, 6 and 7. So 1, 2, 3, 4, 5, 6, 7. I made here 7 rows. You can also do that. If you are using notebook, then please don't keep it vertical, make it horizontal, so more columns, because we have to fill here 18 column like that. So that much space is required. Now second column I had to draw here in this way and connect out immediately. Pause this video and first draw this much towards left hand side. Again start out video, make 2 columns less and draw 10 columns here. First, second, third, fourth, fifth, 6, 7, 8, 9 and 10. I am revising 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. After 10th column, don't rub out this, it should be there. I am increasing out height again and draw here this way. Now make it complete. Afterwards you can complete. Now make here 5 columns. So only this much I am completing this. I want to manage like this. Then rise out 1 step ahead here, same, and make complete. Now we have to draw complete line here. Pause this video and try to draw this way. This is just skeleton of periodic table. Now you will get idea that how to draw this periodic table first. Yet I have not named anything. Alright, so this is first skeleton of periodic table we are produced here. Then make here a line and show a separate row at end. Same way make here a line here, make here a line and show again separate row over here. This is entire skeleton of periodic table. I hope you are able to draw this. Purposefully I have not made here anything, so we are making column afterwards. You are aware now this is about the skeleton of periodic table, and now I have to name this system. Now chemistry is having various problems like ancient concepts and newer concepts like that. So first I had to show old concept, and now after showing old concept we are switching to new concept. Now I had to name this. So this was named as 1A. Name this as second A or 2A. Don't name here 3A, but name here 3. Now all these 10 columns we are naming as B. So then this as 3 B. Then Roman letters all 4B, 5B, 6B, 7B. All right, till here it's all right. But then all these 3 columns are named as 8B. Okay, so this column, and this column, they are named as 8B. Then don't expect 9, expect 1. So this is 1B and this is 2B. Getting idea? So all this central column we are named as B, whereas this is A. Now here again I have to name 3. Now here onwards all these columns are A. So 3A, 4A, 5A, 6A, 7th A, this should be 8A, or many times we are calling this as 0 group. So either 8A or 0 group. This is old nomenclature, numbering structure, where I have to use Roman letters and it is divided into A and B like that. So 1A, 2A like that. Now try to make this numbering. This is old numbering. Now IUPSC, that is International Union of Pure and Applied Chemistry. So that IUPSC decided that there should be uniformity, and so they are naming like this. The names are given in Roman letter, English letters, not in this way Roman. So this is first column, this is second column, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So in red color I have shown modern concept that we are using today. In blue color I have shown old concept. So this way the numbering of elements that is carried out over here. This is the numbering of column. Column means vertical lines. We are saying this as column, or we are rather saying this as groups. So this is either column or group. Now same way horizontal rows are there. So this is first row, second row, third row, fourth, fifth, sixth, seventh. Don't say 8th and 9th row. This belong to 6th row and this belong to 7th row. So these are horizontal lines we are calling as row, or rather period, and vertical line we are calling column or group. So try to keep this name in mind. And now the main question is that I have to fill elements in this. Now just check out. I am no doubt not computer. I can't by heart all the element in periodic table, and that is not required also. But on demand, whatever required, that is first 20 element, atomic number 1 to atomic number 20. These elements you must by heart. So out of 105 older elements, and modern they are going to produce new and new element. But I should say that 105 element you can keep in mind. Number is more increasing out, day by day new elements are added. But I am writing here 1 to 20 element first, and symbolically hydrogen, helium, that means atomic number 1, atomic number 2. I have to fill like row. I am not filling vertically, I am filling horizontally. Then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is fluorine, F pronunciation is there. Then neon. Now here next element, that is sodium, symbol Na. Then calcium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. You are aware atomic number, I should write here only, 2, 10, 18. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Now here I pronounce fluorine, F, here chlorine. So pronunciation of C, chlorine. Then argon, atomic number 18. Then potassium, atomic number 19. And last calcium, atomic number 20. So these elements, minimum 20 elements you have to by heart and place in periodic table. Now for my chemistry study I required first group also. So I am completing out hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So I must by heart these all element also. Again here 0 group, helium, neon, argon, krypton, xenon, radon. Then halogen group, fluorine, chlorine, bromine, iodine. So this way I have filled part of periodic table which is of my use. I have not filled any element in this section and this section, so I must start this also. So I have to fill this block because no element, single element is written in this particular B block and this bottom. So I am going to fill here. Okay, you need not by heart this all, but if you by heart then all right. I am writing here with different color, therefore scandium, atomic number 21, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Zinc is having atomic number 30. So these elements you can, if you are able to by heart, keep it. All metals are there. This element here, I am marking here lanthanum, whereas this element is actinium. So from lanthanum this series is there, we are calling this as lanthanide series, and from actinium this series is there, we are calling that as actinide series. So I have to write some element over here, or say forget off because it will be too much. So right now I am not writing, but when time comes I have to write there. So these elements minimum you have to by heart this way, whatever obviously given here. This is the periodic table and we are having now discussion on periodic table. The entire chapter, keep in mind, if you want to study out chemistry in detail and you have to enjoy study, then you must have thorough knowledge of periodic table. In order to get periodic table knowledge, you must have knowledge of electronic configuration and atomic structure. And then only we can discuss various facts of this world, of this universe, and how this universe is made up of. Why Aulukya or Kanad was saying the world is manifestation of smaller particle, that is called as atoms, like that. Let us check out now. I am coming to the point here. We have to make, obviously there must be notebook in your hand, pen, and you have to write down electronic configuration. Try to write down electronic configuration of hydrogen. I am writing over here. Now the problem is that if periodic table I have to discuss, then for other discussion I don't have that much space. I am discussing over here. So hydrogen electronic configuration is 1s1 here. The next element helium, it is 1s2. Lithium 1s2, 2s1. I hope you are also writing out. Then I am writing out neon configuration, which is 1s2, 2s2 and 2p6. I am not splitting out p shell because it is completely filled. So if at all split, it is 2px2, 2py2, 2pz2. Then sodium, it is 1s2, 2s2, 2p6, 3s1. Sodium onwards, argon, it is 1s2, 2s2, 2p6, 3s2, 3p6. Again, split is not necessary, but if you want to split, it is 3px2, 3py2, 3pz2. Potassium, okay, forget of that. You will find that every period means horizontal, every period begins with new shell. Say here principal quantum number is 1, here the last shell principal quantum number is 2, here last shell principal quantum number is 3. So like that, every period begins with new shell. That's why earlier I said that not only atomic number but electronic configuration is also considered in case of periodic table. So every period begins with opening of new shell or new principal quantum number. Okay, so in case of first period, the principal quantum number is under construction, that is 1. In case of second, the principal quantum number under construction is 2. In third, principal quantum number under construction is 3. Like that. In case of potassium, you may check out yourself, you will get 4s1. In case of rubidium, 5s1 and so on. So you can check out any electronic configuration here, you will get same concept. The electrons are added. Say for example now magnesium, what I should do? 3s2. Aluminium, 3px1. Silicon, 3px1, 3py1. Phosphorus, 3px1, 3py1, 3pz1. You check out yourself, you will get that no new quantum number is added, principal quantum number is same till here. Argon, 3p6, that means principal quantum number in case of argon is 3. In case of potassium, it will be 4. So from here to here, the principal quantum number will be only 4. So like that, last shell principal quantum number, that will be 4. So like that, this is characteristic of periodic table, that every period begins with new principal quantum number and ends with that principal quantum number only.